we are going to solve short type numerical problems. That means in this type of numerical problems we have to find out moment of resistance, area of steel. So these are we have to find out. These are short type problems. Let's start first problem. Determine the depth of a neutral axis of a beam 350 mm by 600 mm with 4 bars of 20 mm diameter. Also check for the type of section. Use M20 concrete and Fe415 steel. To solve any problem, first of all, we have to read out the problem very carefully and you have to understand what are the given data, what is already written in the question, and what is the demand, what is the actually question. So the beam which is given, cross section of the beam is width 350 mm and depth 600 mm, and in this section 4 bars of 20 mm diameter is used, and grade of concrete is M20 and grade of steel is Fe415. That means given data is FCK, that means characteristic strength of concrete, is 20 MPa or 20 Newton per millimeter square. Whatever you want, you may write the unit. Fy is 415 MPa. B, small b, that means width of the beam is 350 mm. Small d, that means depth is 600 mm. First of all, we have to find out the area of steel. Look, in question, diameter of reinforcement bar is given, that is 20 mm. So cross sectional area of any circular section is, we know, pi by 4 d square. So here we have to find out the cross sectional total area of 4 bars, that means the total AST, area of steel. So 4 number of bars multiplied by pi by 4 multiplied by 20 square, that is equals to 1256.64 mm square. Now we have to find out depth of neutral axis. So as per IS 456 Annex G and clause number G11, the formula you have already seen the how the formula comes from the assumptions and where the formula written. In my description box, the video link is already given. You can check the link to know where is the formula in IS code. Okay, so the formula is XU by D, that is equals to 0.87 FYAST by 0.36 FCK B into D. So that is equals to 0.87 into Fy is 415, as we see as per question, and area of steel, as we find out, that is 1256 into 1256.64 by 0.36 FCK, that is 20 mm, into B, small b, that is width is 350 mm and depth is 600 mm. So from this we may write XU, that means depth of neutral axis, is 0.3 into 600. So we have got our first answer of the question, that is the depth of neutral axis is 180 mm. So now we have to find out the next answer for the question. The next question is the type of section. For that we have to find out the limiting value of neutral axis, that is XU max. So as per clause number 38.1 of IS 456 2000, actually just below the clause number 38.1 we have a table I have described the table in previous video. The link is given below in description box. You may find out that xu max by d is equals to 0.48 for Fe 415 grade steel as per the table. Now so xu max is equals to 0.48 into 600, that is equals to 288 mm. So from this we may find out that xu is less than xu max because value of xu is 180 and value of xu max is 288 mm. So xu, that is actual neutral axis, is lies just above the critical neutral axis, that is xu max. So this section is under reinforced section. So these are the two questions, the answer of the two questions. The depth of neutral axis is 180 mm and the section is under reinforced section. Now let's go to problem number 2. Let's read out. Determine the moment of resistance of a beam of dimension 300 mm by 400 mm. The area of steel have 3 bars of 16 mm dia. Clear cover is 35 mm. Use M20 concrete and Fe 415 steel. So as per question, we have to find out moment of resistance, and diameter of the beam is 300 mm, width, that is small b, and depth, that is overall depth, is 400 mm, that is capital G. So, clear cover is mentioned here 35 mm. So to find out the effective depth from total depth, we have to deduct the clear cover and half dia of reinforcement bar, that is half of 16. So small d is 400 minus within bracket 35 plus half into 16 bracket close, that is equals to 357 mm. Now we have got effective depth for this section, that is 357 mm. Now we have to find out area of steel first. So there are 3 number of bars and cross sectional area is pi by 4 into 16 square. So total area of steel AST is 603.185 mm square. Now FCK, as per question, the characteristic strength of concrete is 20 MPa or Newton per millimeter square, and Fy for Fe 415 grade steel is 415 MPa. Now we have to find out the depth of neutral axis from Annex G and clause number G11 of IS 456 2000, and the way the formula is written actually, that is also described in my previous video. So to find out that, you have to check my previous lecture. The link is given below the description box and you can get the link from the suggestion also. So xu by d, the formula xu by d, that is equals to 0.87 Fy AST by 0.36 FCK BT, that is equals to 0.87. Fy is 415 for this case, and AST you have find out 603.185 by 0.36. FCK is 20 for this case. Small b, width is 300 mm into small d, effective depth that we find out is 357 mm. So xud is equals to 0.282 from this equation. So now we have the value for xu by d. Now we have to find out the limiting value of neutral axis. Limiting value as per the table just below the clause number 38.1, xu max by d is equals to 0.48 for Fe 415 steel. We have used Fe 415 steel for this case, so the value is 0.48. So we may say that xu by d, that is the value is less than xu max by d. So the section is obviously under reinforced. Now moment of resistance, we have to find out what is asked in the question, and the formula we have get from Annex G of IS 456 2000. As I said earlier, the detail of this formula is given in previous lecture. You can get it from the description box. The formula for under info section, mu equals to 0.87 fy ast into d within bracket 1 minus ast to fy by bd fck. So that is equals to 0.87 into 415, that is fy. Ast is 603.185 into d is 357 within bracket 1 minus AST is 603.185 into FI is 415 by B is 300 into D is 357 into 20, that is equals to 68.7 kilonewton meter. So where is the answer? Value of moment of resistance is mu, that is equals to 68.7 kilonewton per meter. So the answer is mu, that is moment of resistance, is equals to 68.7 kilonewton meter. That's all for this lecture. Thank you.